Hi, I'm Scott, and I'm the treasurer for the First State Woodturners. Each year we send out a survey to the membership, and the number one most requested topic that we cover is bolt turning. So this video will be about the basic information that you'll need to get started bolt turning. But first, let's talk about safety. The most important thing before starting any wood turning project should be your personal safety. So it's going to be up to you to read and understand all the documentation and safety information that came with your equipment, including your lathe and any other power tools that you'll be using. Also, it should include the documentation that came with any supporting equipment like chucks. In that documentation, you'll find size limitations for your specific chuck and or woodworm screw, and all that information there is to keep you safe. So please read the information, understand it, and know your limitations before you get started. Before we get started, you're probably going to want to know how large a piece of wood will fit on your lathe. Now you can check that in your owner's manual, right? And it should give you the swing of your lathe. Now the swing of your lathe is going to be measured by doubling the distance from the bed to the spindle. Now you might think that's the biggest piece you can fit on your lathe, and technically that's correct. But you might have to worry about the banjo. Okay, so the banjo is going to take up some significant room underneath your turning, so you may want to consider that when measuring your blank. Next, let's talk about the equipment that you're going to need to turn a bowl. So first up, definitely going to need a bowl gouge. You're also going to need the center points that came with your lathe. You're going to need the live center that goes in the tailstock, and you're also going to need a drive center that goes into the headstock. You may want to use a faceplate. Okay, so this one came with my lathe, but if you're going to use a faceplate, you're going to need appropriately sized screws that match that faceplate, and we'll talk more about that later. Okay, and although not 100% necessary, although extremely highly recommended, you're probably going to want to use a chuck. There's some other tools that you might use, right? Like a bandsaw or a chainsaw. If you have them, great. If you don't, maybe you have a friend who does. Okay? And there's going to be some other tools that we're going to need that I'll mention in the video as they come up. So let's talk about gouges. I have 3 different gouges here, and let's start with this one. Okay, this is a spindle roughing gouge, and we are never going to use this for bolt turning. It's extremely dangerous. Enough said about that. Let's just put it away. All right, and so now I have 2 left, right? I have one is a bowl gouge and one is a spindle gouge. So let's take a look at those. If we take a look at these 2 gouges up close, we'll see that they both started out very similar. They're both made from round bar that's about a 1/2 inch. Okay, but that's where the similarities end. You can see here that the spindle gouge has a shallow flute compared to the deeper flute in the bowl gouge. Okay, so the bowl gouge is specifically designed to turn bowls. So when we're bowl turning, we're going to use a tool that was designed for bowl turning, and we're going to use a bowl gouge. Now, we might wind up using a spindle gouge occasionally for some detail work, but the vast majority of the turning you're going to be doing, turning a bowl, is going to be with a bowl gouge. Let's take a quick look at the center points that you're going to use on your lathe. So this one is a live center, and it's got a ball bearing in it, and this is the one that came with my lathe. And yours may look similar, slightly different, but it's going to be the one with the bearing in it, and it's going to rotate. So let's just put that away. So what we have left is the collection of drive centers, right? So this is just the spur drive center, and this is what most people are going to get with their lathe, and this will work great. So if you have something like that, that's perfect. All right. These other 3 are variations on a theme and are designed for safety, right? So this one has these small teeth, okay, and it's designed that if you have a catch, since it's not as much bite, that the teeth will slip. All right, this is a one-way safety center, and they took it a step further, okay, and took the teeth away completely. So the only thing that will drive your blank, if you use this center, is going to be friction, okay? But if you have a catch, the wood will stop moving, okay, and the catch will not be catastrophic. Now, this is a robust safety center, and you can see that it has something very similar. The inside is just like the one-way, okay? But where the one-way is smooth on this collar here, the robust is threaded, and what's threaded onto that thread is this collar or this outer ring, which just gives a little bit more surface area. So also no teeth, smooth on the outer ring, smooth on the inner ring, and this will just give you a little bit more friction when you're turning your blank. Okay, so if you're going to buy another drive center, you might want to consider buying one of these safety type centers. To turn a bowl, you're going to need a faceplate or a chuck. So let's talk about faceplates first. And you can see here that they're not all created equal. We got a 6-inch, a 3.5, and a 3-inch faceplate, and with all different hole configurations. You know, this is also made out of cast iron, this is aluminum, and this is steel. So they're not all exactly the same. So if we take a closer look at these faceplates, we can see that on this larger faceplate, all the holes are countersunk. And on my medium-sized faceplate, also countersunk, but the holes are not countersunk on this smaller one. And I picked this as just a cheap faceplate that I picked up off the internet. Before we talk about screw selection, I turned these faceplates over because I thought it'd be important to take a look at the underside of these faceplates. Now, it's hard to notice here on the one-way faceplate, but it's very obvious here on the one I got from Robust that the underside is also countersunk. And we take a look at this internet faceplate that I picked up, and no countersink at all. The reason these two faceplates are countersunk on the underside is for when you drive a screw into the piece of wood that the faceplate is going to be mounted to, some of that wood is going to be drawn up while you're driving the screw in, and the countersink gives an area for that wood to go. On a faceplate like this one with no countersink, that little bit of wood that gets drawn up could tilt the faceplate slightly and throw it a little bit off of balance. So let's talk about screw selection for your faceplate. First, we're going to talk about this cheap faceplate I got off the internet. Since there is no countersink, we're going to need a appropriate screw that does not have a countersink, just like this panhead screw. Okay? We're also going to make sure that the size is right. And to make sure that the size is right, we're going to want the largest screw that will fit into the hole. Now, this is a size 10 screw, right? And if I took a size 12 screw, which just this so happens to be, it will not fit in the hole. So the size 10 screw with the panhead is the right screw for this faceplate. Now, if we take a look at this Robust faceplate, right, we have countersunk holes, so we're going to need a head that is countersunk, okay? And also, we want the largest diameter screw that will fit into the hole, and for this faceplate, it's going to be a size 12, okay? So that's how you check to make sure that you have the right screws for your faceplate. The only other consideration you're going to need to know is the screw length. The general rule of thumb is that you're going to want to have at least 7 threads that protrude out from the faceplate, okay? Now, obviously I have more than 7 threads here. Some people opt to even have longer screws, but you generally want at least 7 threads coming out of your faceplate. So what size faceplate should you use? Well, the general rule of thumb is to use a faceplate that is 1/3 or larger than the diameter of the blank that you're turning. But once again, check the documentation that comes with your equipment and follow the manufacturer's safety directions. Let's take a quick minute to talk about chucks. They're not all created equal, so you're really going to have to do your research before buying a chuck, right? They're not all the same size, okay? And they don't all necessarily fit your lathe. So you're really going to have to check to make sure that it will work with your lathe. Now, I've turned these two chucks over just to show you a difference in how these chucks are made. This one has a direct thread, so this is threaded to fit my spindle, okay? This one has an insert, so this insert is threaded to fit my spindle, but this insert then threads into the chuck. So if you're gonna buy an insert chuck, you're gonna need to make sure that you buy the appropriate insert for your spindle size. The documentation that comes with your chuck will explain how large a blank you can turn with the standard jaw set that came on the chuck. So just as an example, this large Vicmark 120 chuck with the standard jaws, according to the manufacturer's instructions, say that this will turn or will safely hold work up to 24 inches in diameter with the standard jaws. And in contrast, this Easy Wood Tools Easy Chuck with the standard jaws, the manufacturer's instructions say that these jaws are capable of holding bowls up to 6 inches in diameter. Now, with that said, if you don't have a lathe that can turn a blank 24 inches in diameter, right, you might not need a chuck this large, right? You might be able to use a smaller chuck and just buy a separate set of jaws. Generally, chucks come with interchangeable jaws, but the jaws aren't all created the same. You can see that the jaw set for this Nova chuck, has holes for screws because that's the way the jaws are held on, where the jaws for this Easy Wood Tools chuck, it has some internal mechanism that holds the jaws in place. So you're going to need to buy jaws that fit your chuck. So both of these chuck manufacturers have tables in their directions that lists the size of the blank that you can turn depending on which jaw set you have in place. So please, once again, consult the owner's manual before mounting any blank onto your chuck. If you bought your chuck new, it should have come with a woodworm screw. Okay, and you can see the Vicmark screws are both identical, regardless of the size chuck. Okay, the Nova chuck screw is slightly different, although very similar. Okay, and then the Easy Wood Tools woodworm screw is completely different. So this one only works in the Easy Wood Tools chuck with the standard jaws in place. Okay, so it's really important to understand what woodworm screw do you have, what size hole you're going to need to drill to use this woodworm screw, and how deep that hole needs to be. So once again, consult the owner's manual for your own safety. Since this is a video about bowl turning basics, I'm going to shoot for a modest size bowl, let's say about 8 inches in diameter. Right? If you have a lathe that's larger or smaller, you might just have to take the information and scale up or down accordingly. To turn our bowl, we're going to need a piece of wood. Now you can go out and buy a commercially available bowl blank, but these blanks are expensive and probably not the best way to learn turning a bowl. All right, a little bit less expensive is to go to your hardwood dealer and buy some dimension lumber. Now this is some 8/4 maple, and I could use this for a bowl blank. But also it could get expensive, and you're very limited to the thickness that's available at your hardwood dealer. Another alternative, and the cheapest, because usually it's free, is to cut your bowl blank from a log. Okay, and we'll talk about that next. I have this log up here on my lathe to show where we're going to get the blank from for when we butcher up a log. This red circle is the pith of the log, so we're going to want to avoid the pith completely when we're cutting out our blank. Since the pith is located pretty much in the center of this log, it really wouldn't make any difference where I positioned my blank, okay, because the pith is centrally located. But what if there was a large offset between the center of the log and the pith? Okay, it might not be the best idea to cut your blank with the pith offset from center. As the wood dries, it's going to warp, and it's going to not warp symmetrically if the pith is drastically off center. So if your pith is offset from center, try to find a place where you will get a symmetrical blank out of your piece of wood. With this piece of wood here, I have some cracks radiating away from the pith going this way. All right, so I opted to draw this out to show where I would cut a blank out on this log. Here you can see I drew in where some growth rings would be So you can see that the center of the log is going to become the top of the bowl, okay? And the outside of the log is going to be closer to the bottom of the bowl, and that's where our tenon is going to be. Okay, so here we are at the wood pile, and you can see I got our log up on, basically on a couple other logs that I'm just using to hold this up. And what I'm going to need is I'm going to have to kind of just draw out where I'm going to want my bowl, okay? Or where I'm going to want the blank for my bowl. So the dead center of the log is the pith, and what we're going to want to do is we're going to want to cut that completely out of our piece, okay? So I'm going to go a little bit, maybe an inch, half inch, 3/4 of an inch. I might even do more than that depending on the size of the log, but for here, and I'm just going to use this lumber crayon, and I'm going to mark on one side of that pith, okay? And that's going to be a cut line for me. And then I'm going to just go here to the other side, right? About the same amount of distance, okay? And I'm going to just draw another line. Okay, so those are going to be where I'm going to cut, all right? And so this half will be one piece, this half will be another piece, all right? And what I'm trying to do is I'm trying to cut this pith completely out of the log, all right? All the cracking as this log dries is all going to occur. It's going to start right here at the pith and radiate out. So it already has some cracks. There's one running up this way, one running down this way. So I want to get rid of all those cracks completely and just cut that pith completely out. Okay. And also, it's just going to be easier for me since I have this log here is to just kind of determine how deep I want my bowl. And let's just say I'm going to go about there. All right. So I'm going to draw another line. Okay, so I drew another line. I'm actually going to cut that off with the chainsaw, okay? And I'm going to do the same thing over here, okay? I'm just going to cut this end off. Okay, and you'll see why in a little bit. I mean, that's going to just make my life a whole lot easier when we get this all butchered up. I'm going to just set my compass here and I'm going to just kind of check. All right, and that's actually pretty good. All right, so I'm actually going to bury this end in here. All right, it's just so it stays, and I'm just going to trace the circle. All right. So now that I have this circle traced out in the blank, I have two choices. I can either take this back in to the shop and I can actually cut this out on the bandsaw, right? I got a nice circle. You kind of see why I made that edge flat, right? So I can actually then cut that on the bandsaw, all right? And I can get myself a nice blank out of there. Or if I don't have a bandsaw, right, I can just take my chainsaw and just start nibbling away and get me mostly round. So for today, bandsaw. It's cold out here. Once our blank is cut, the best thing to do is to turn it right away. But if you don't have time, you're going to have to find a way to seal the wood to prevent it from cracking. So you have a couple options. If it's just going to be temporary, you could just wrap it in plastic. If it's going to be sitting around longer than a day or two, you might want to consider covering the blank in anchor seal or one of the many other products that are out there that are made just specifically for sealing wood blanks. Now I have a blank cut, and if I cut my blank out of a piece of dimensional lumber, or if I did a good job cutting my blank out of a log, right, it's going to be symmetrical with a nice flat surface, and I should be able to just mount that either onto a faceplate or a woodworm screw. But if the piece is out of balance due to either the log shape or maybe I did a less than stellar job nibbling away the corners while I was cutting out the blank, there's still hope. I'm looking for about 800 to 1000 RPM when I'm turning this piece. So if it's out of balance, I'm going to mount the piece between centers and adjust it until it's balanced. And then I'll be able to get the speed up fast enough to turn it easily. As I remove wood to bring the piece into balance, I may need to readjust it between centers just to keep it balanced on the lathe. Once I'm done, I should have a nice symmetrical blank with a flat side, which will be the top of the bowl. Now it's ready to mount either on a woodworm screw or a faceplate. So let's start with the worm screw. Here you can see I have a chuck on the lathe and I have a worm screw. And the worm screw has like a little shoulder on the inside that will fit against the back side of the chuck jaws. So let's put that in and tighten up the jaws. And we're going to want to pull the screw forward or out of the chuck until that shoulder engages the back of the chuck jaws. If you don't do that and you tighten this down and it's not fully out, while you're turning, this could slip, and just a little bit of slippage could make your blank start to wobble uncontrollably and could be very dangerous. So we're going to make sure that the screw's pulled out as far as it'll go and the shoulder's engaged on the back of the jaws, and then tighten the jaws up just enough to hold the screw in place. Okay, now after we've drilled an appropriate hole in the blank with the appropriate size drill and to the appropriate depth, now we can take our blank with an appropriate size hole and thread it onto the worm screw. Now I'm just turning this spindle wheel to get it started, and once I have it started, I'm going to lock the spindle, and then I'll turn the blank until I have the blank seated as flat as possible against the jaws of the chuck. And there we go. Here I have a wood blank, and you can see there's a center mark right in the middle where I had my live center into the wood while I was surfacing off the face of this so it would have a nice flat surface, right? And I got a faceplate, so I could just eyeball this, right, and just do the best I can, right? And that'll get me pretty close to having it centered, right? But I want to be as accurate as I possibly can. So what I did was I just turned this little faceplate center finder, and it's just a piece of wood that fits into the faceplate, okay, and there's a little point, okay, and at that point we'll find the little dimple that was left by my live center, okay, and now I know that the faceplate is centered on the center hole that was left by my live center. Okay, so now I would just have to put some screws in. So when I put the screws in, okay, what I'm going to do is I'm going to start with one, and I'm going to put the screw in, and I'm not going to tighten it all the way down, and then I'll jump across to the opposite one, and then I will start to tighten down the screws. And that's just, if I tighten down the first one, sometimes it has a tendency to torque the faceplate a little bit, right? And I don't want that to happen, right? So I will start with one screw, and I'll tighten that up, and then I'll go to the opposite side, and then I'll go off at 90 degrees, and then the opposite side, and then kind of just alternate, just like I was tightening lugs on a, lug nuts on a car tire. For this next method, I'm going to bypass the woodworm screw and the faceplate completely, and we're going to take the blank and mount it directly to the chuck. For this method, I'm going to start with the blank between centers, and I'm going to true it up and then get a nice flat surface on the top of the bowl. Next, I'm going to remove wood away from the center so I can cut a recess. After that, I'll use a tool like a skew, or in my case, a bidan, and I'm going to cut an appropriate size recess to fit the jaws of my chuck. Once that's done, I'll be able to turn the piece around and mount the chuck into that recess, and then I'll be ready to go. So there you go, 3 different methods on how to get your bowl blank mounted on the lathe. Are there more? Probably. Which one's best? It just comes down to personal preference. The ultimate goal here is we want to have the top of the bowl facing the headstock when it's mounted on a lathe, because the first step we're going to do is we're going to turn the outside and we're going to form a tenon so we can turn the bowl around and then hollow out the inside. Here you can see my bowl gouge, and if you look between the tip and the heel, the bevel kind of forms a straight line. Okay, and that straight line is going to be the direction of the cut. If you're going to want to cut deeper into the wood, you're just going to have to turn the tool slightly and it'll follow the line of the bevel. If you want a shallower cut, then you will just turn the tool in the other direction. And so let's say you were just taking off this corner, right? You would just tilt the tool slightly in the other direction and it would follow that bevel. The same is going to be true of this bowl gouge, which is ground at a 40/40 grind. Here you can see I have both gouges resting up against the wood on the bevel, and you can see that the angle that I'm having to hold the tool to maintain bevel contact is completely different between the swept back 65-degree gouge and the 40/40 ground gouge. Once I have our blank mounted up on the lathe, I'm going to need to true up this surface. So I'm going to take the bowl gouge and I am going to open up the flute just a little bit. So this would be closed. This is fully open, so I'm just going to open up just a little bit and I am going to just take the tool and cut sideways. The process is going to be exactly the same for the swept back grind as it is for the 40/40 grind. The only difference being the angle at which you have to hold the tool to maintain bevel contact. Next, I'll be doing a planing cut, and I'll be using just the front corner of the gouge from the nose to about maybe a third of the way down into the wing. And I have the tool handle held low, and I got the tool rest very close to the wood, and I'm just going to pull the tool across the wood surface, okay, and do a planing cut. And it'll work the same with the swept back grind and the 40/40. Once you have the face all trued up, you're probably going to want to cut a small dimple into the dead center of your blank for alignment purposes later. And to do that, I'm going to use the tip of a skew. Next, we'll need to cut a tenon into the blank so we can turn the piece around later to hollow out the bowl. You can do that with a pencil or with a set of dividers. If you're going to use dividers, make sure you only touch the point that is closest to you. If you touch the trailing point, the blank will flip the dividers right out of your hand. When turning the tenon for your blank, you're going to have to decide whether to use a faceplate or a chuck to remount the bowl. If you're going to use a faceplate, you're going to have to turn the tenon of sufficient size to fit the faceplate that you're going to be using, and the tenon is going to have to be long enough to accommodate the screws so the screws don't go into the bottom of your bowl. If you're going to be using a chuck, you're going to have to turn the tenon in the proper shape to match the jaws in the chuck that you're using. Some jaws require a straight tenon, some require a dovetail. They're not interchangeable, so know what you need and check the owner's manual. You're also going to need to turn the tenon of sufficient size to match those jaws. So once again, please consult the owner's manual and make sure that you have the proper shape and size of your tenon so you can turn your bowl safely on your lathe. Now it's time to put a tenon on our blank, and I'm going to use a 40/40 gouge because that's what I'm used to. But the same principle is going to apply regardless if you use a 40/40 or if you use a swept back gouge or even if you're using carbide. The principle is basically the same, but I'm going to use what I'm comfortable with. So we're going to form a tenon and a shoulder. To form the tenon and shoulder, I'm going to use the same planing cut that I used to surface off the face of this blank. Here you can see I have a tenon in the shoulder, but I need to clean this up, and to do that and give myself a nice dovetail and a nice flat surface, I'm going to use a skew. The jaws on my chuck require a dovetail. Your jaws might be different, so check the owner's manual. And I cut a nice flat surface on this shoulder that will sit on top of the chuck jaws. I tried to cut this either perfectly flat or slightly concave, so the outer rim will be a little bit taller than the inside, so the outer rim will sit flat on the chuck jaws, so that'll mount this blank on the chuck as stable as possible. Now I can start shaping the outside of this bowl, and I'm going to start by just removing this corner. Now that that corner is removed, I can start working on these corners and round the outside shape to give the bowl a nice curve. Now that I have a nice shape on the bowl here, I am going to use the lower wing of my bowl gouge and just kind of blend in the area that I couldn't reach because of the shoulder. Okay, I did that with just a shear scraping cut. So now that we have the outside of the bowl all shaped up, it's time to take it off the lathe and then remount it. Okay, so if you have it mounted on a faceplate, we're just going to unscrew the entire thing from the lathe. If it's on a woodworm screw, we're just going to unscrew it off the screw. And if we have it mounted on the chuck, we're just going to, adjust the jaws so we can remove the blank and remount it on the lathe. When remounting the bowl to your chuck, we're just going to put it on loose so it doesn't fall out, but still not tight. And slide the tailstock up onto your blank and lock it down. And then we're going to tighten up the tailstock to force that shoulder onto the top of the chuck jaws so it sits nice and flat. Once it's flat, then we can tighten up the chuck and tighten up both sides, and then we're ready to hollow out the bowl. Once we have the bowl blank secured in the chuck, we can then loosen up the tailstock and just move it out of the way, right? If your lathe is small, you might need to take the tailstock completely off the lathe just so you have unimpeded access to hollow out the bowl. You don't want the tool or your arm hitting the tailstock while you're trying to hollow the piece out. With the tailstock out of the way, I have total access to do what I need to do to this blank. And the first thing I'm going to do is I'm going to surface off this face just with a planing cut. Now that I have a nice flat surface, I can start hollowing out this bowl. I'm going to hollow from the inside out, or from the center out to the rim. I have a decision to make though at this point. I have to decide whether or not I am going to make this a once-turn bowl and turn it to final dimension and then put it away, or if I'm going to make this a twice-turn bowl, which means I'm going to leave it thick and then put it away and then turn it again after it has dried and warped. Okay? The nice thing about the twice-turn bowl is once you turn it after it is dry, it's not really going to warp anymore. The once-turn bowls are unusual. They have their own appeal, but they're all warped. So there's no right answer here. It really comes down to personal preference. I make some of each, but for this one, we're going to make this a twice turn bowl, and let's hollow it out. I moved the camera around a little bit so you could see kind of what I was doing. And what I'm doing is I'm starting out with the rest adjusted, so my tool is basically on the center line of the bowl, and I'm going to have the flute of the gouge closed. I'm going to scribe a line with the point, and once that line is scribed, it gives something for the gouge's bevel to ride on. And then once I have a nice surface for the bevel to ride on, I'll open up the gouge slightly, and then I'm just going to push straight in. And pushing straight in will give me this 40-degree cut because of the bevel on my 40-40 grind. These next few passes are being done with a 65-degree swept back bowl gouge. So you can see the process is really not that much different. Here you can see a line I marked on the blank in pencil. And that's going to be my guideline on where to stop when I'm hollowing out this bowl. The general rule of thumb on the wall thickness for a blank that you're going to put away and turn again later once it's dry is about 10%. So it's going to be about 1 inch for 10 inches. Now our bowl blank here is about 8.5 inches across. So I don't think anybody's going to complain if I made this just shy of 1 inch. You can see here I'm only going in about 1 inch and then moving back towards the center and starting over. And that's just to keep the blank stable. The more mass there is on the inside of the bowl, it'll keep the walls from vibrating. And even though I'm leaving this about 1 inch thick, and it's probably not going to make all that much difference, it's just a good practice. Each grind can have its advantages and disadvantages. Now the 40-40 excels at hogging out wood, and it does it very efficiently. But one of the downsides is, since I need to maintain bevel contact through the cut to the bottom of the bowl, I mean, you can see here that as I get close to the bottom of the bowl, that I risk hitting the tool on the side of the bowl. And if I lose bevel contact, I'll lose control of the tool. In contrast, you can see what would be more of a standard grind or swept back grind. I can reach the bottom of the bowl and still have plenty of room to clear the side of the bowl. So to completely avoid hitting the side of the tool on the edge of the bowl, I'm going to use a bowl bottom gouge, or some people might call it a bottom feeder gouge. Oh. All right. So now our bowl is rough turned and ready to be put away. You saw there at the end I chamfered both the inside and outside corner here, and that's just to help prevent it from cracking. The wall thickness is just shy of 1 inch all the way through, and I can tell that just by feeling it. If you don't feel comfortable with that, you could have drilled a hole 1 inch or slightly less than 1 inch shy of the depth of the piece, right? And then you could hollow to the bottom of that hole that you drilled, right? You could also, if you knew the width of the blank, you could just measure with a ruler. Or, I mean, if you really want to be super accurate, you can go out and buy something like this. This is a Tompkins bowl gauge, and you could just put this on the bowl and you can actually measure the wall thickness. Okay? But for a rough turn bowl, it's really probably not going to be that critical. Maybe for a finished bowl, but you can pretty much just feel that it's about the same thickness throughout the piece. So now we have a nice 8.5 inch-ish bowl blank ready to put away. All right? So how do we put this away and keep it from cracking? Well, first let's just chat real quick about why it's going to crack if you do nothing. the outside is exposed to air, and this is also now the outside, even though it's the inside of the bowl. But anything that's exposed to air is going to dry significantly faster than the wood that's on the interior. Okay? And as the wood dries, it shrinks. So as the shrinking wood shrinks too much, and it is not shrinking at the same speed as the wood on the inside, the wood starts to crack. So we want to prevent that from happening, so we need to slow the drying process down. And how do I do that? Personally, I put the blank in a paper bag. Okay? Now I'll just put that paper bag in my shop, and I don't have any problems cracking. But my humidity in my shop might not be the same as it is for you. You might need to use 2 bags. You might need to put wet shavings in the bag to slow down the drying process. I used to, in a previous location, I used to have to put the drying blanks in wet shavings in a bag in a cardboard box just to slow that drying process down. So after you put a few away and you look at them, you'll know if you have it dialed in right. If the bowls are cracking, you need more moisture, so you're going to need to protect them more. If the bowls are getting moldy, they're not drying fast enough. Okay? So you might be able to then take away something that you're currently using. Like if you're using the cardboard box with wet shavings, you might want to try a paper bag with wet shavings. Or you might want to just try a paper bag with no wet shavings. The bottom line is you have to find the right combination that works for you to slow that drying process down. You might even want to just paint the entire thing with anchor seal and just put it away. All right, so how do you know when the bowl is sufficiently dry and you can turn it again? The best thing to do is to go out and get like a food scale. You can then write down on your bowl how much it weighs when you turned it. And then you can come back every week or so and reweigh that piece. All right? You'll see it's going to continue to lose weight. Once you get to the point where it's no longer losing any weight and it hasn't lost any weight for a few weeks, it's probably as dry as it's going to get. And then you can then bring that piece back in and return it a second time. Now there's other ways to dry your bowls. Some people will say you can put them in the microwave. Some people will have a kiln special made for their shop. Some people will say to put the bowls in alcohol or to put them in boiling water, and those methods may or may not work, okay? But they're also outside the scope of this video. So I air dry everything, and I just put the pieces away and I take them out when I know they're sufficiently dry and then return them. Well, that's it for this video. Next up, we'll take the once turned bowl, we'll put it back on the lathe, and we'll turn it that second time to give us a final piece. So we'll see that in a month or two. All right, well, thanks for watching. If you have any questions, feel free to ask.